Hello guys, this is Pedro Cadenas and I'm going to be talking about a Python, which is a dynamic programming language compared to C, which is a static programming language. First, I will create this program over here into a Python version, and we'll see the differences and how basically you create one. So let's first do create a file, give me that py. Now let's start by creating a size array, a variable. We're gonna set it up to 1000. As you can see, I don't need to do int, double, or anything to declare the what size will hold. For a dynamic programming language, it will figure out for you, which we'll talk about the disadvantages about that. I will also create a double array over here, which I already copy and pasted. Basically, from 0 to range, create a list of this size, and each index of that list creates a list of this size. And then now let's go into the for loop. I will click a space right here just on purpose, and you'll see why later. I will do for I in range between 0 and size. So we're going to create a matrix that takes in we're gonna make a matrix of 1000 by 1000 and then set each value to 1. I know this is a dumb program, or it's not, I wouldn't say dumb program, but a simple program, but I'm only creating it because I am trying to drive a point home for you guys. So matrix ij equals to 1. Now, as you can see, we don't need colons. It's a lot more readable compared to the C version, and there's a lot of variables that I have to manage with. Now, to create a for loop, let's do k in range from 0 to 500. So I am going to add up all the values of the matrix into a sum value. Let's create the sum equals 0. And this sum value basically 500 times. Again, in order to drive the point that I want to show the performances compared to C, and we will time this program as well. So I in range between 0 to size, and then a final third loop, j in range from 0 to size, and then matrix sum equals matrix, and then we're gonna make this I j, and actually we need to add the sum, right? If not, we're not adding anything, we're just gonna get 1. And then another feature for Python is you can reuse variables to hold other things that it usually use. For example, matrix is basically quote-unquote int matrix. I can use an index of that matrix in order to basically hold a string. So let's use the index of the matrix 1010, and we're going to create a string. The sum is, and creates plus, and then this stir basically takes in a value and creates a string equivalent. And then we're going to print matrix 10 10 10. So this basically should compile, not compile, but run correctly. Let's test it out. Python, give me some py. Oh, it says, sorry, this doesn't work, unexpected indent. So this is why I did that indentation on purpose. So indentation is an important thing for this programming language. In C, you can do all the spacing over here, so it works because of these curly, curly braces. Over here, you actually have to make sure everything's indented correctly. If not, it will not work. Now let's try this. That worked. Let's do control. I will do control Z. Right now we're just interrupting it because I want to time it. So let's time Python, and then give me that py. So as it runs over here, let's run it over here. We're going to already have it compiled, so I'm going to do time, and then we're going to do matrix matrix.c. No, yes, matrix. So as you can see, this took almost a second long, which is somewhat good because we're going through the matrix 500 times. And over here, as you can see, it's still running. And I did not test it out very thoroughly, but I think it should be running. There we go, perfect. So it took about 30 seconds. So it's doing the same calculations. As you can see, 5 million is the result. But this took 30 seconds compared to this almost barely a second. 30 times the amount of time. And that's what we're gonna basically dive into on the presentation part. So why is it slow? It's basically sorry about that, it's my phone. Why is it slow? Python is dynamically typed. Basically it figures out what the variable has when it's being used, mainly because, and it also uses more memory because all these variables are objects, and these objects contain things in them to determine the type and then set up the value, and then basically based on this type it will do the correct operation, and then it's interpreted rather than compiled. Basically for a compiler it optimizes the program for the programmer. It basically sees any redundant code that can be omitted without affecting results, while in Python it doesn't do that. It will just do it for you because it's interpreted. It would just, there's no optimization there's for the compiling. If we go, and we're going to show you an example of why it's so slow. C code is basically this is Z code for adding two numbers. So assign 1 to A, assign 2 to B, and then do the binary add, and then basically get to the result. Pretty simple, shouldn't take long. Now let's go into Python. A lot more complex. It basically each step has substeps. So to assign a value, it takes 2 steps compared to 1. So first it determines what 1 is. If it's an integer, so type code. If it's an integer, a double, and then it sets a value. So this has to be done for both variables. Then to call the binary add, it basically has to get what the variable itself is, then get the variable from A, and then the same thing for B, and then call the add. 4 extra steps, I think, and then this also creates different objects in order to save those results. So more memory is being used in order to save the result into C, and then you finally create C and then save that result there. So as you can see, this is why it's so slow and why it uses a lot of memory. And you're gonna say, like, why do you want to use Python then? Basically, for education reasons, the scientific field uses this a lot better. Memory is not a concern. If you want to make a program a lot faster and with less resources, Python's the best thing to do. Has a lot of library support. It's easy to read, as you actually saw, and also it's less prone to errors because you are not creating a lot of variables. You don't have to keep tracking back and forth. And for my simple program, you saw that it used a lot less space, and I didn't need to do a lot of comments. And yeah, basically that's it for my video, guys. Thanks for watching. Bye.